Welcome to this lesson on Amazon EMR, which stands for Elastic MapReduce. EMR is Amazon Web Services' powerful solution for big data processing using industry-standard frameworks like Hadoop and Spark. Throughout this lesson, we'll explore how EMR enables organizations to process massive amounts of data efficiently and cost-effectively in the cloud. Amazon EMR is a fully managed big data platform that allows you to process vast amounts of data without worrying about the underlying infrastructure. Think of it as a service that handles all the complex setup and maintenance of big data systems for you. With EMR, you can run Apache Hadoop and Apache Spark workloads on the cloud, enabling you to analyze petabytes of data for tasks like analytics, machine learning, and data transformation. The key benefit is that AWS takes care of all the infrastructure management, so you can focus entirely on your data processing needs. EMR consists of 4 core components. First is the cluster, which is a collection of EC2 instances that work together to run your big data frameworks. Second is the node, which represents each individual EC2 instance within the cluster that performs specific tasks. Third is the application component, which refers to the big data frameworks you choose to run, such as Hadoop, Spark, Hive, or other tools. Finally, there's the step, which is a processing unit that submits your actual work to the cluster for execution. These components work together to create a complete big data processing environment. EMR clusters use 3 types of nodes, each with a specific role. The master node acts as the manager of your cluster. It coordinates how data is distributed across the cluster and monitors the health of all nodes. The core node is where the heavy lifting happens. These nodes run your data processing tasks and also store data in HDFS, which is the Hadoop distributed file system. Finally, task nodes are optional nodes that only run processing tasks without storing any data. Because they don't store data, task nodes are perfect candidates for using AWS Spot instances to reduce costs significantly. Apache Hadoop is a foundational framework for distributed big data processing, and it runs seamlessly on EMR. Hadoop consists of several key technologies. MapReduce is a programming model that processes data in parallel across multiple machines in your cluster. HDFS, the Hadoop distributed file system, stores large datasets by distributing them across multiple nodes for redundancy and reliability. YARN, which stands for Yet Another Resource Negotiator, acts as the resource manager that allocates cluster resources and schedules jobs efficiently. Hadoop excels at batch processing, making it ideal for large-scale extract, transform, and load workloads where you process massive datasets in scheduled batches. Apache Spark is a more modern and faster alternative to Hadoop MapReduce. Spark's biggest advantage is its in-memory processing capability, which makes it up to 100 times faster than traditional Hadoop MapReduce for certain workloads. Spark supports real-time data processing through Spark Streaming, allowing you to analyze data as it arrives rather than in batches. It also includes MLlib, a built-in library for scalable machine learning algorithms, making it perfect for training models on large datasets. Additionally, Spark provides multiple programming interfaces, supporting Scala, Python, Java, R, and SQL, giving developers the flexibility to work in their preferred language. EMR provides 3 main storage options to suit different needs. HDFS, the Hadoop distributed file system, provides temporary storage within your cluster while it's running, but this data is lost when the cluster terminates. Amazon S3 is the most commonly used storage option. It provides persistent, durable storage for both your input data and output results, and data remains available even after your cluster shuts down. EMRFS, which stands for EMR File System, is a connector that allows Hadoop applications to interact directly with S3 as if it were HDFS. This combination gives you the best of both worlds. The familiarity of HDFS with the durability and cost-effectiveness of S3. EMR offers 2 primary cluster launch modes to match different use cases. Transient clusters are designed for batch processing jobs. These clusters automatically terminate once your processing steps are complete, making them extremely cost-effective because you only pay for the compute time you actually use. This mode is perfect for scheduled ETL jobs or periodic data analysis tasks. Long-running clusters, on the other hand, remain active continuously. These are ideal for scenarios where you need constant availability, such as interactive data exploration, real-time analytics, or when multiple teams need to submit jobs throughout the day. The choice between these modes depends on your specific workload patterns and budget considerations. EMR delivers several compelling benefits for big data processing. Autoscaling automatically adjusts your cluster size based on workload demand, ensuring optimal performance without manual intervention. Cost optimization is built in, as you pay only for the resources you actually use, and you can further reduce costs by using spot instances for task nodes. As a fully managed service, AWS handles all the heavy lifting of provisioning, configuration, patching, and maintenance, freeing your team to focus on data analysis rather than infrastructure management. Finally, EMR integrates seamlessly with other AWS services like S3 for storage, DynamoDB for NoSQL data, Redshift for data warehousing, and many others, creating a comprehensive data processing ecosystem. EMR is widely used across several critical big data scenarios. ETL processing, which stands for extract, transform, and load, is one of the most common uses. Organizations use EMR to extract data from various sources, transform it into the desired format, and load it into data warehouses for analysis. Log analysis is another major use case, where EMR processes massive volumes of server logs, application logs, or clickstream data to extract valuable insights about system performance or user behavior. Machine learning practitioners leverage EMR to train and deploy models on large-scale datasets using Spark's MLlib library. Finally, data analytics teams use EMR to run complex queries and perform sophisticated analytics on petabyte-scale datasets that would be impossible to process on traditional systems. These use cases demonstrate EMR's versatility in handling diverse big data challenges.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.